Good morning, guys. Today we are going to talk about graphing systems of equations by graphing again. So solving them by graphing, except now we're going to deal with a little bit trickier of equations. So a system of equations is a set of two or more equations with the same variables. A solution to a system of equations is a set of values for the variables that are true for all the equations simultaneously at the same time. The intersection of two graphed lines is the solution to a system. We have to solve, so this is our new steps, okay? This is all should be a review from the last two classes. But now this is where things get a little tricky. The first thing we haven't had to do yet, but we do now, is we have to solve both equations for y. In other words, we need to put the equation in slope-intercept form, which is that y equals mx plus b. And then using the slope and the y-intercept, we're then going to graph both lines on the same coordinate plane, and then we will find the intersection if it occurs. Remember, if it doesn't occur, if there's no intersection, if it's parallel lines, there's no solution. If it's the same line, there's infinite solutions. So once we find that intersection, if it occurs, this point of intersection is the solution to our system. So now if we look at this system of equations, this is a little different than what we've seen the last two classes, because this equation is we need to rewrite. The 3x plus y equals 9 is not in slope-intercept form. This one is. I can easily go graph this one. So I can go graph this one over here. My y-intercept's -1. My slope is -1. So I go down 1 over 1, down 1 over 1, down 1 over 1. And that's my line. This one is not so easy. I need to put it in slope-intercept form first. So I need to solve for y. I need to get y by itself, which means I need to move this 3x to the other side of the equation. So if I'm looking at this, all I'm going to do to move it is I'm going to subtract it from both sides. Now I have y equals, I'm not going to put down 9 minus 3x. I'm going to put the -3x first so that it looks like this mx plus b form. If you put 9 minus 3x, it's still a correct way to rewrite it, but we want to put it in slope-intercept form. So now I have this equation, and now I can graph that one. So I'm starting at the y-intercept of 9, and I go down 3 over 1, 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 and I see that they intersect here. Now I'm going to name that point of intersection. That is 5, -6. That is my solution to the system. Okay, let's do another example. This one's perfectly fine. I can go ahead and graph that. So I'm going to start at 3 on my y-axis. That's my y-intercept. And then my slope is -2. So down 2 over 1, down 2 over 1, down 2 over 1. And I could keep going if I want. This one I need to rewrite. -x plus 2y equals -4. I need to rewrite that. This one's even trickier to rewrite than the first one. So I'm going to put it down over here. First thing I want to do is get this y alone. So I'm going to add this x to both sides. So that gives me 2y equals x minus 4. Remember, I'm going to put that x first. The other problem here is I have this 2. I don't want it there. The 2 is multiplying by the y, so I'm going to divide it on both sides. Now here's the key thing. This 2 has to be divided by everything on this side. So there's essentially a 1 here. That has to do 1 divided by 2. So now I have y equals 1/2 x. And then I have to do -4 divided by 2. So that would be -2. So when you divide that 2, it has to be divided by every value on the other side. So now I have this. I'm going to put my dot at -2, excuse me, on the y-axis, because that's my y-intercept. And then I can go up 1 over 2. See the intersection, up 1 over 2. So my intersection there is at 2, -1. And that would be my solution. Let's do one more of these, and then you will get to practice. This one, I want to rewrite this equation, 6y minus 3x equals 6. I can graph this one starting at -1 on my y-axis, because that's my y-intercept, and then up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and I can go backwards, down 1, left 2, down 1, left 2, down 1, left 2.
Will the following teachers please report to the main office?
Excuse this interruption.
Mrs. Macaroon, Mr. Lukowitz, Mrs. Becker, Mrs. Hendola, Mrs. Larock, Mrs. Tyler, Mrs. Richards, Mr. Tingley, Mr. Naughton, Mr. Rockwell.
Hold on a sec, guys.
Mrs. Farrell, Mr. Foreman, Mrs. Pankowitz, and Mr. Streeter.
Sorry, a lot of teachers out, I guess. Using the slope-intercept form now, I'm going, well, first I got to rewrite this equation. So I'm going to rewrite this. First thing I'm going to do is I want this y by itself, so I'm going to move this 3x over by adding it because it's negative. So now I have 6y equals 3x plus 6. My last step here, I want to divide this 6. I sometimes write it like this just to remind myself that it has to be divided by both things. So now I have 3 over 6, which is a half, and 6 over 6, which is 1. Okay, now I'm going to graph this. I have my slope is a half, my y-intercept's 1, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Now, these actually are parallel lines and they don't intersect. Okay, so there is no solution here. Now, an easy way to tell there's no solution when it's in slope-intercept form is if the slopes are the same and the y-intercepts are different. Okay? Whew, sorry. All right, so that is what you'll be working on today. I hope you guys have a wonderful day. Let me know if you have questions. There are office hours later today. Have a good one.